Give a brief introduction to our project, and then I'll turn it over to Cecilia to talk more about what the workshop plans and goals are. But before I start, I want to acknowledge all the people that are part of this team, and I'm going to have them raise their hands so that you guys can know here who's all involved in this project. So you have myself, Julian Stroeve, and then you have Cecilia Bitz, who everybody probably knows, and we have Ed Blanchard-Wigglesworth, who's right here. We have Hayo Eichen is actually not here today, but he's also part of this project. We've got Larry Hamilton, he's sitting in front, and we got Elizabeth Hunke. Yep, there she is, okay. And we've got Jennifer Hutchings, back there. Phil Jones, there you are, great. Walt Meyer, and Jim Overland, great. Oh, Adrian's not here. Oh, okay, so we have one other person who won't be here, Adrian Tivy. And then we have Moyen Wang, great, and then Helen Wiggins. Okay, great. So for some of you guys, what I'm going to show briefly, you may have already seen as part of our webinar, or also our AGU town hall meeting. And some of you were also at the IGS meeting where I also briefly discussed our project. But basically, you know, a lot of the reason why we're all here is we're really interested in what's happening to the Arctic sea ice, and we're interested in how we can improve sea ice forecasting, which has become a really big priority for a lot of different stakeholders. And a lot of this builds off of what the SEARCH folks have been doing for quite some time, where since 2008 they have been soliciting community input of predictions for the September mean extent from different researchers or teams that are interested in doing sea ice forecasting. And all of this has been disseminated through the ARCIS website. And I think a lot of you are probably familiar to that effort and have contributed forecasts to the SEARCH Sealce Outlook. And we know there's a wide variety of techniques being employed, and using heuristical or statistical tools or modeling. Larry's going to talk a little bit more later today about sort of how these forecasts have been done and how well they've been doing. And we have about 309 contributions that we've received so far between 2008 and 2013. And Larry will talk more about that later this morning. So what our Sea Ice Prediction Network is basically we have this newly funded project that is funded by many different agencies. So we have support from NSF, we have support from Office of Naval Research, from NASA, from NOAA, and so a lot of different people are being funded to tackle this effort. And really our basic overall goal is to try to improve sea ice prediction on sort of seasonal to interannual timescales by really bringing together a network of scientists and stakeholders that are all interested in this topic and want to work together to try to advance the research on sea ice prediction and then communicate what we know about the ice and disseminate it to the general public as well as relevant stakeholders. And this work really builds on the SEARCH Sea Ice Outlook. So this is kind of where it's all coming from, is trying to take the SEARCH Sea Ice Outlook, which started out as an informal effort, and try to make it into a more formal network. And really do it a little bit more rigorously in how we're handling the predictions. And we sort of envision that our Sea Ice Prediction Network will kind of now act as the custodians for the SEARCH Outlook, and maybe doing this by forming an action team that's going to oversee the SEARCH Sea Ice Outlook in the future now. So the way we have our proposal structured and the way we're looking at doing all of this is to have a formation of action teams. We think that that might be the best approach to sort of tackle this problem. And so we have 4 defined action teams that we listed in the proposal. And so one of them is just focused on basically coordinating predictions and evaluating how well they're doing, looking at hindcast evaluation, sensitivity studies. And this is being led by Cecilia Bitz. And my part of it at NSIDC, and together with Walt Meyer at NASA, is to really look at integrating, assessing, and guiding the observations that are needed to improve sea ice forecasting. And then Jim Overland, together with Moyen Wang, are also looking at synthesizing the predictions and observations. So they have their own action team. And then finally, disseminating predictions and engaging the key stakeholders. And this is being really led by Larry Hamilton and Helen Wiggins at ARCIS. Excuse me. So with this project, of course, there's a lot of synergy with SEARCH. And one of SEARCH's new 5-year goals is actually to improve sea ice prediction and advanced sea ice prediction. And so they have an action team sort of dedicated to this. And that action team is actually being led by Jennifer Francis and Henry Huntington at SEARCH. And so they're focused on looking at daily to decadal timescales, and we're more sort of in the seasonal, maybe the interannual timescales for our sea ice predictions. So we kind of fall right within what one of SEARCH's 5-year goals that they have. We look at working with SEARCH to seek advice and sort of consensus from SEARCH on the direction that the Outlook should take. So, how we should start doing our predictions or disseminating results. What are we looking at? Are we just looking at September mean extent? How far should we expand this out? There's been some discussions even at the IGS meeting recently that we shouldn't just limit it to the Arctic, that maybe it should also be the Antarctic. But we look at having Outlook fall under the umbrella with our new project, but then through coordination with SEARCH still. And with Hayo Aiken, and he's unfortunately not here, but the SEARCH is definitely partnering with other groups such as Access, the Norwegian Research Council project, as well as Alaska Community Observers. And Hayo has a whole list that he's been looking at where SEARCH sea ice partnerships that he's been active in forming. And you can just kind of get a look at some of these different partnerships. There's international and national partnerships that SEARCH is involved with. And so our project also then sort of falls into these sort of collaborations with these different groups and partnerships. And so that's just sort of a brief overview that I wanted to give on our project, and then I'll turn this over to Cecilia.
Well, it's my privilege to welcome all of you to this workshop. And I'm really pleased that you could all make it, and I'm excited about our opportunity to talk about sea ice prediction for the next 2 days. We also have some listeners online, probably, and so we'll be broadcasting, and that will require just a little bit of extra effort on our part, which I'll explain. But I'll start also by thanking our sponsors. NCAR has been tremendous by giving us this facility and actually working with us to broadcast, and all the audiovisual support has been spectacular. So if you have any opportunity to say thanks, please do. There are actually a number of people from NCAR here. Would you raise your hand if you are? It's yeah, about 5, 6, something like that. And they'll also be able to help you find the restrooms and cafeteria. I can as well. So the workshop was sponsored financially by the Department of Energy, and we're really grateful to them. And did you want to say anything about that, Phil? Just okay. But that's just for the workshop. Then, as Julian mentioned, our project itself is a multi-agency support project. Then I'll just briefly say what our goals are for the workshop, and it's to make recommendations primarily for the SEARCH Sea Ice Outlook. So by the end of this meeting, we'd like to have some really well thought out, firm recommendations. And we don't really get to make the final decision. We'll do that in consultation with the SEARCH Scientific Steering Committee, but we feel like we're probably going to have a lot of input into that. Also, if you're not into making these outlets, don't worry, because we have a lot of other goals for the workshop, which is really to advance the science of predictability and to make a set of experiments that we can coordinate together to really advance the science using a model into comparison project approach. We'll also be talking a lot about data sets, and we have experts here on observing and creation of data sets and the formatting of data sets, so we'll be doing a lot of interaction on that level as well. We want to consider some other ways of visualizing prediction using new and better metrics, and we have experts in the room today who are experts on prediction metrics, and I'm really looking forward to hearing from them as well. We do have a session on stakeholders and communicating science, which should be pretty interesting. And then, of course, we want to network and get to know each other. I don't want to go through the agenda because I've printed them out, and you can pick up a copy. This is primarily for the people who are viewing. But I will say we have this participant session starting at 1 o'clock. So it'll be mostly just the Sea Ice Prediction Project team, people speaking in the morning. And then we'll shift over to, in fact, everyone after that lunchtime will be not part of the team, but participants, except for Ed has a little bit involvement after lunch as well. And I did on the agenda that we printed out put the names attached to the order that we'll have you go, so in case you're interested. Day 2 is similar to day 1, and it's also on the agenda outside. I did want to say one point, that is I had to put some participants speaking on day 2, and it's not meant to be a punishment or slight. I didn't mean to slight you at all. I'm really sorry that we couldn't have everyone speak on day one. But when I asked for people to speak, there had an overwhelming response of people who wanted to speak. And so we slipped some of those into talks tomorrow. And also, we do have breakout sessions tomorrow morning. So that means that then those talks by participants are actually after the breakout sessions, which I realize isn't ideal, but it's just the way we were able to schedule the rooms in the building. So I do, instead of having everyone just go around the room and tell me your name, I thought I would have something a little more interactive where you get to raise your hand in response to a question. And so I want to ask, who submitted a Pan-Arctic sea ice outlook? Oh my gosh. So some of the 309 outlooks we've seen. How about a regional outlook? I'm guessing not as many. Yeah, 2. Okay. Who's involved in developing sea ice models? You can raise your hand more than once. A lot of people. Yeah, you count. And I mean this in a very, when I use the term model for this week, we're going to use this in a very broad sense. Statistical, analytical, mathematical models, numerical models, time-stepping models. Okay, who works primarily on sea ice prediction? Not necessarily sea ice, but you can include sea ice if you want. Yeah, a lot of people. Okay. And then who works for an operational center? I mean, somebody who has to get out the prediction no matter what. Yeah, okay. Quite a few. Who's an observer who's interested in how their data can improve predictions? Yeah, quite a few. Excellent. And who's interested in stakeholder and communicating science? Quite a few. You're not the only one, Larry. Larry's our expert, and Helen, of course. Who's a program officer? Excellent. Yeah, thank you. And graduate students among us. This is in part so you can find each other. You're still a graduate student for a few more days, aren't you? Oh, no. Francois has been promoted. And who's within 5 years of their PhD? You can raise your hand. All right. And then finally, who didn't get to raise their hand? All right. Oh, no. Excellent. OK. We do have a few brief requests. And these are minimal to indicate your preference for breakout sessions. There are 5. And I've got them with all of your names. And you can write in if I don't have your name on the sheet. The 5 are listed on here. I'll say them really quickly. Recommendations for the next generation sea ice outlook. Design of intercomparison experiments for sea ice prediction. Design of metrics to validate prediction. Recommendations to stakeholders and improving communications and observing needs for data formats for initialization. So I'll hand these around so you can sign up. Please show your first, second, and third choice, and we'll have probably 2 separate sessions, so you'll get 2 of your 3 choices. And then, so that's the first request. And the second is I screwed up when I asked you to fill out the webcast forms and had them mislabeled. So I'm going to probably run around the room and ask you to sign the right form. I'm sorry about that. So I screwed up. And then finally, all the talks are loaded for after lunch except for Wisla. Oh, we got yours this morning, but not Felix. So we'll have to do that during lunch because at the break time we have a complicated activity to try to switch to a speaker who's going to come over the wire. So we can't do that during breaks. Ooh, these are a little out of order. Did you want to say something about travel reimbursements now, Phil? Yeah.
Back to us, you want to just scan receipts and want to give them to you get those receipts and the forms back to us accurately. And second issue is that if you are a foreign national and come over, please make sure to check the visa template. Not a tourist. Dave, if you have any questions about it.
Thanks, Phil. Thanks for dealing with all of that. Finally, housekeeping. I think a couple people have asked about toilets, up or down the stairs, either way. And then go to your right, and if you walk about 15 or 20 steps, there will be signs off to your left. It's not as simple as, I can't tell you exactly where to go, but the sign should lead you. And I guess there's also one across from reception, which I learned about this morning myself. We're not supposed to have food and beverages in here. I have a beverage in here. So obviously, we're going to break that. But please do your best not to spill, and if possible, don't bring them in. But whatever, do take out your trash, because this room isn't cleaned. And then we didn't get funding for food and beverages. So this is the one thing we couldn't spend DOE money on. And so we asked for a donation, and it's $25 for both days, and there's a little box outside. So please do go ahead and just throw it in the box or give it to me. And then finally, if you do go outside during lunch or during a break, I wanted to show you how to get back in. That's about where we are in the building. We're kind of in the middle. And it's really tempting to go outside, and you can go outside by going up the stairs and then out the back door here. So it's, oddly enough, you have to go up a level, but that's the best way to go out. But the door's locked. It won't let you back in unless you have one of these swanky in-car key codes. So you need to go back to the main entrance, and the best way to do it is to go around the north-ish side of the building. South side, lots of traps. Don't do that. And then at the end of the day, the bus pickup is, I assume that's where they left you off as well? Yeah, good, back where they left you off. And then last of all is the microphone. When you put on the microphone, if you can, try to put it in your center. And apparently it's not good if you keep your name tag on because it rustles around. So try to remember to take your name tag off. And then do it as quickly and quietly as possible because it makes a lot of noise, apparently, on the web broadcast. Okay, we're ready to go to the next person, which is Jim. And we didn't expect any questions, but we'll have a lot of time for discussion later. So Jim, come on up. And I'll queue up the talks. And we will have time for discussion or questions probably after Jim's talk.
Well, good morning, everybody. Nice to see you here. The SEARCH Outlook started about 6 years ago at a meeting near Lamont. And the idea was there were a lot of uncertainty, multiple mechanisms for sea ice loss. We had the 2007 minimum that was well below the trend line, and the idea was to get a forum set up where researchers could discuss the various physical mechanisms involved. I like to give our thanks to all of those that submitted outlooks to the Sea Ice Outlook. Early in May every year, it's like you're having a party, but is anyone going to come? You know, and I'm grateful to say we had about 20 submissions every year that made it a viable product. And as Julia said, the purpose of this meeting and the next is to up the level in the next 5 years, where it's still a major research activity. The idea is at least to think in terms of how it would move towards operations. So everyone has used this figure probably 20 times themselves, but I just wanted to bring out part of the consensus then on what was going on. We have a long-term downward trend going back to the beginning of the satellite era. In 2007, there was a shift in the meteorology. The dipole pattern for the Arctic was basically higher pressure over the Beaufort side that enhanced the sea ice melt. Classically, the summer Arctic, the pressure fields are flat. You have a little storms generated near the coast that wander out in the center of the Arctic. So the fact that you had a Beaufort High develop, and I always think of the Beaufort High is only there in the fall and the spring, but now it's been there enough that it's in the climatology for the summer. When we got to 2012, there wasn't a real strong weather component to this case. It looked like it was a shift over to a result of thinner ice. And in this last summer, we went back to the classical weather pattern of not much going on. And so if you think of that as kind of the range of weather, there's a question of whether, the slope of the trend line is increasing in the last 5 years or not. And that's the kind of arm-waving level that the Sea Ice Outlook has operated on. And as you all know, it's really not just the extent, but it's the loss of volume and multi-year ice. And this is Ron Kwok's picture where you went to. We seem to have some kind of shift around 2005 and to very little multi-year ice, and the epiphany was it takes multiple years to grow multi-year ice, so it's not easy to go back to where we were before. Even if you had 4 or 5 real cold years in a row, it still would be hard to go back. So when I give general talks, that's the Arctic really is a leading indicator of Arctic change, and it has to do, as you all know, with you grow ice in winter and melt it in the summer, and that's actually a fairly sensitive balance. You get out of whack on that, and that's a bigger, more easily positive feedback than global change at mid-latitudes. There are strong drivers out there. In the U.S., Arctic will probably be drilling again within 3 years. It's not just Shell, it's other companies as well. So even though Shell has had some problems, the driver for multiple countries are there. It's a rough time if you're a walrus in summer. You've essentially lost your habitat in the Chukchi Sea. And as we all know, the opening of ice-free areas is a positive feedback in the whole climate system as well. So there's lots of large drivers for what we're doing. And this is some of the fine print in the Sea Ice Outlook that no one reads. But it's not a formal consensus prediction. Although Ron Lindsay, when we started out, always reminded me, if it quacks like a duck, it's a forecast. So it gets used in that, but you know, we do have the disclaimer, and that it was a forum for the community to discuss sea ice on the web, and it's really, what's really clear, and this is true going forward, is this is not at all a replacement for the national forecast centers, although we're very pleased that in several countries the forecast centers are playing along and are part of the development. Okay, part of this is the reality check that, you know, formally it's really hard to do sea ice predictions beyond a couple weeks, and that's you know, that's something we always have to keep in mind. And when we started out doing a seasonal Arctic-wide outlook, that wasn't an arbitrary decision. The point is that if you do seasonal average and Arctic-wide average, the central limit theorem helps you where if you have large anomalies in different months, they'll tend to cancel out. And so like 2007, you had a weather anomaly in all 3 months, which gave you that extreme. So, you know, so when people are interested, you know, stakeholders are interested in regional and a couple of month forecasts, we take that in, but that's a much more difficult problem than defining, keeping it in an Arctic-wide seasonal, even though people don't know what to do with that number when you've got it. For developing intuition, that was the idea. And we also requested quantitative outlook numbers, and that's not because we believe that people could do it that well, but it was a way of sharpening your, you know, if you have to pick a number, it sharpens your intuition, was the logic on that. And there's some psychology going on too, year after year. The first year that we did it, these are the results, and here's 2007 and 2008, and we have a very wide range of opinion of what would happen. Some people would say, well, we're going to stay down around the 2007 number. Some people thought, well, you know, we're on the downward accelerating slope, and some people said we would go back to the trend line. So this was very pleasing because it wasn't a matter of verifying a forecast, it was that we had the range of opinion on what the physics was doing. But then everyone got smart, I guess, or something in the following years, and everyone tended to end up close to the trend line. So on 2 out of the remaining 5 years, we didn't even bracket the observations that year. Everyone tended to cluster on there. So that has some implications, I think, on how we go forward. That we were talking before there, you know, we always compared this to the climatology, but if the null hypothesis was the trend line, that's going to be pretty hard to beat. And So going forward, I don't, on a science basis, we don't want to lose the idea that there's large uncertainty in the whole process, especially at regional and monthly scales. So it's not to ignore what might be stakeholder interest, but we need to figure out the different levels of uncertainty for the different potential products. But I don't want to be a Debbie Downer on that. I think going forward, we're really in a pretty good place that we can think about encouraging more modeling groups to get involved and do probability-based outlooks that the trend line is essentially the expected value, but it would be nice then to have ranges on that, and you know, the German group has been doing that already, and a leader on that. In the physics, you know, the models are getting better, and part of what we're thinking here is making the databases more accessible, that when you're initializing the model at the end of spring, you really have had to run the model through the winter, and if we're assimilating data, and also we're getting in the realm of seasonal atmospheric forecasts from several different modeling centers. And in the past, what the modelers have done is take historical summer weather from a whole lot of different years, but some of the forecasting centers are actually doing seasonal forecasts with multiple ensemble members. So the transition from where we were was more of an ad hoc research arm, and I would propose that we still think of it as a research project, but we're keeping in mind applications. And part of that, when we've talked about it, is we already have a very long list of web resources that Helen has put together, but to expand that and make sure that all the information is out there. So in terms of regional or monthly, the data is there. There could be a discussion of what's going on a regional basis, and we include that, but it would be more at the discussion level, where the art wide, we would continue that way. And looking forward to talking with you the rest of the week.
Okay. Well, I just to build on what Jim said, I looked at the SEARCH Outlook for some years now, and I thought it quacks like data, and that this is really interesting. The charts that Helen and the other SEARCH Outlook people have been preparing every year, or actually 3 times each year, the bar charts that Jim was showing you, are accumulating into more and more guesses, or predictions, or forecasts, or whatever they are, quacking. And it just seemed like an interesting project to do a meta-analysis and see how those broke down. So we've written that with Julianne and Cecilia and Ed. This paper is just coming out. The preliminary typo-filled version is online at Geophysical Research Letters. And if you want the non-typo version, write to one of us, and probably in a week or two, I think, hopefully we'll have it. So just to recap, since 2008, the Sea Ice Outlook, organized by SEARCH and with participants in this room and others, Ohio and elsewhere, have been soliciting predictions or forecasts of September mean ice extent 3 times each summer. I believe it's the first of, is it early May, June, July? End of May. Okay, thank you. So anyway, lead times of about 2 to 4 months, and there are 3 cycles. And so far, we've accumulated about 309 predictions through this, or they have. I wasn't part of the data collection. And in some years, these predictions exhibit collective skill. I know Jim pointed out they were never meant for this, but nevertheless, it's interesting to see collectively how they do. And in some years, they do very well. In other years, they do not do well at all. And this pattern appears unrelated to the type of method that's used, and rather it deals with the characteristics of the year itself. And that highlights some room for future development in sea ice prediction. Key points in our articles: the analysis of SIO contributions, 2008 to 2013, has a bimodal pattern of success. Either they're collectively right or they're collectively wrong. Years when the observations depart from the trend are the ones that are hard to predict, despite whatever preconditioning people took into account. And statistically, it appears that year-to-year variations dominate the success of the ensemble predictions. And I'll show you what we mean by that. These box plots are all 309 predictions. The little red dots are the observations, the actual September mean ice extent. And the box plots are the distribution of SIO predictions in the 3 monthly cycles each summer. And if you scan across this, you can see that 2008, so you've got June, July, August in each of those triplets of box plots. You can see that the, say in 2008, the median of the July predictions is pretty close to the actual observed extent. In 2009, not only is the median not near, but not a single one of them was near. 2010, the median is just about spot on. 2011, the median is just about spot on. 2012, not a single one of them is near the observed extent, and 2013, almost as far off. So this is a bimodal pattern I was talking about. We can formalize this a little bit by working with quantile regression, and what you see here is the red observations, the red dots again are the observations, and the line with the little circles is the median of SIO predictions. These are the July SIO predictions, just to simplify, for each of the 6 years. And the shaded area is the interquartile range. That would be the middle 50% of the predictions for each year. And again, you see that 3 years stand out as being well predicted, at least in terms of the median, and 3 years nowhere close. This is not what we expected to see, by the way. I thought the consensus would probably be tracking the reality very well, but reality is always more complicated than our hypotheses. In later years, the SIO also asked people to quantify their uncertainty, and they did this in a lot of different ways that aren't formally comparable. Sometimes there'd be standard deviation, or confidence intervals, or interquartile ranges, or something that was unspecified. But just taking those at face values for an informal comparison, I've drawn, these are, I think we have 15 separate predictions here. I've subdivided them according to the way that SEARCH has been doing, SIO has been doing, into statistical and modeling-based predictions. And I've drawn the user-supplied uncertainty limits around this. And then the gray line at the bottom is the actual value. So these are July 2012. And you can see that not only are none of the point estimates accurate, but very few of the intervals even contain the actual observed extent. So this is one of the miss years. It would be a dull graph in the hit years because they're all right on. Another of the years in which most of the estimates were off is 2013. And again, you see this pattern that not only is the actual value indicated by the gray line different from the median, from the point estimates, it's outside the uncertainty bounds that most of the estimates gave. So it was doing something different. What was it doing? The red line here is the observed September extent, 79 to 2013. And at lower right, you can see a series of dots, which are the the median SIO predictions. And you'll see that they more or less obey the trend line, but do not particularly capture year-to-year variations. And this is the pattern, that in years when the observed ice extent is more or less on its trend, then the predictions turned out to be right. And I think in some cases that's because they actually were using the trend for the prediction, but in other cases they were using other things. And so it's dependent on how they were making the predictions very much. I'll say one other thing about detrending. I mean, my viewpoint is a little bit statistical. The trend looks very nonlinear, and if you subtract a linear trend, you get correlation among the series that is due to the fact that they share nonlinear components. So detrending is a little more tricky than you might think. If you graph the prediction errors, the SIO, the observed sea ice minus the SIO median vertically against the observed sea ice minus a Gompertz curve trend, you get a correlation above 0.9. In other words, where it deviates from that curve is where the predictions were wrong and in the same direction. And then there's a more technical analysis where we test some hypotheses. If you speak multiple regression, this will be the part of the paper, and if you don't, you want to skip it. But it's a quantile regression of the median absolute error. On the first column is just on terms for individual years. And you can see that there are significant departures just predicted by year. In the second column, we add the month of the SIO prediction to see whether there was an improvement in skill as we get closer to September. And the disappointing answer was no. Red indicates statistically significant differences here. So controlling for a year, there's not an improvement from the May to the June to the July predictions. At least not in the median. There may be in individual predictions, but not in the median overall prediction. The third column, we add an indicator for whether they were modeling or statistical-based predictions, and that turns out not to be significant either. No significant difference there. And the fourth column, we excluded those data that were classified as contributions from the general public. These were mostly in the last 2 years when SIO became more popular, just to see if we drop the non-scientists from the list, do we do any better? And not very much changes. So these conclusions are robust. These conclusions are robust. There are various decisions made in the analysis and coding and so forth, and you could change all of those, and I think you'd get essentially the same conclusions. I'll wrap up with a couple of things that didn't make it into the article. I was very disappointed, but the reviewer said we had to cut them. One of them, these are office pool data. The one on the left is from NCAR. I believe that this was a contest for ice cream. And the one on the right is from NSIDC. And what's interesting here is that the medians of those pools were right and wrong in exactly the same years as SIO. And so this, if you set this up beside the similar graph I drew for the SIO earlier, it would be very similar pattern from completely different sorts of data. And I think this is also in the SIO. We did some other analyses about whether preconditioning allowed you to predict better. And this is simply taking the biomass volume estimates and graphing them together with this is biomass March volume along with September sea ice extent, and they correlate really well because they share the same nonlinear trend. But if you take that trend out, the biomass in March does not very well predict September extent. And I think the same is true of some of the other preconditioning measures we looked at. So there's the challenge. That trend, as Jim was saying, it's a very fierce null hypothesis. And we can quantify this. The root mean squared error for the trend is only slightly worse than the root mean squared error for the SIO over the point of this, over the span of these data. So there's the challenge for future work. And I think this is I should wrap up by saying I think this is a fantastic experiment, the SIO, and I hope it thrives. I think it's something new under the sun, bringing all these things together. But of course, you get good and bad news from collecting the predictions in that fashion. So, thank you.
We have time for about 10 minutes of questions. So both Jim and Mary, questions now? Maybe you could come up, Jim, because you'll have to.
We have to share the microphone. Okay.
And please, when you ask a question, keep in the microphone. Oh, I guess I'll. Yeah, you guys.
Supervisor. Thank you. So, if the trend is really a challenge for predictions, are we sure that we can predict the trend, the nonlinear trend, right? And what should we do to predict it right, the right way?
Well, the short answer is we can't, but we'll always have an idea, and that was my point, that the sea ice volume is really the issue going on rather than just the extent. And so I think the curvature you get in there has to do with with that switch. And that's just my arm waving.
Hi. I saw one thing that looks interesting. If you go back to Figure 3A.
See.
Oh, I forgot which slide. Yeah, this one. Look at comparing the forecast and observation. If you shift backward by 1 year of the observation, there's very good correlation. So that means last year's observation. Anyway, yeah, last year's observation has a strong impact on the forecast. There's something.
I think the real issue here is if you're looking at just the median, you're essentially predicting the expected value, which is on the trend line. I think if you look at the work that Bremerhaven has done, where they've done statistical forecasting, as I showed, my interpretation of this point was there was a weather effect that pulled it up off of the line. And the same with the down here. So if we're putting ensemble forecasts with the range of what the weather is over the summer, I think that's how we reduce these outliers. At least these two are, I consider, weather outliers that should not be part of the downward expected value trend. That should get them going.
So that was, he actually stole my question there. I was going to say exactly the same thing, and I think you see this in a lot of prediction, that people are always answering the previous problem, so to speak. It happens in like politics. There's always the people are responding to what worked last time, and things have changed, and so the natural variability of public opinion, so to speak, is not as large as the natural variability of the sea ice system. But it is interesting though, because you can see, you certainly expect that in like the public polls, like the pools. That's a natural thing. But it's fascinating that you see this in physical models, and I wonder, it's something to maybe think about. Is there something? Are we letting some biases into the way we're setting up the models? I know Julian and I, the NSADC one, using Ice Age, we kind of looked at things and said, well, if we use just the average Ice Age, it's way too high. It's things have changed, so we got to sub-select, and that maybe was legitimate to some degree, but then you're kind of biasing yourself. So, and then to do something new, Jim, you mentioned last year, or 2012 was not weather related, although there was the big storm.
Oh, yeah.
So I just wondered if you wanted to comment on that at all, just for clarification.
Just that, 2000, I'll always comment, but, the quick, I like our response we had on 2008 after 2007, because the real question here was this a weather outlier, or was something actually shifting in the atmospheric climatology that would make that dipole high pressure more common, and that in fact was the case until 2013. So now, is this the outlier compared to something where we're steeper down here, where we've lost the sea ice? So I'm not troubled by the outlier results. I think that was a very good place to show exactly where we are, because it divides up the weather part from the long-term trend, and the fact that we're not linear here does pick up whether it's the sea ice is a lot thinner and a lot more mobile, or that's certainly part of it, but maybe the weather is part of that too.
I'll just add to that. We had some discussion about this as we were writing the paper. To what extent is it a summer weather effect that is kind of a ceiling on the prediction accuracy? And to what extent are there just other cues in the earlier season that we just were not adequately picking up at this point? So that was an active discussion we had, and I think we're cautiously optimistic about it. But clearly, to the extent that what this variation is July weather, that's going to be very hard to predict.
Well, and it's a question of there were 4 months of weird. There were 4 months of weird high pressure weather in 2007. In these other years, we would have 2 out of the 4 months would have that high pressure pattern, and then it's sort of gone in the last year. So it's a mix.
Firstly, I'd say that, it's probably pretty clear that most groups are underrepresenting their error, just by the fact that it's not within the range of possibilities. But given that, and given that there is such large error and essentially such a large trend, can we actually do better? Can you actually do better than forecasting the trend? And would we do better, especially if we do it in a deterministic fashion? Maybe has anybody looked at looking at this in terms of probabilistic forecasts? Is there a better? I'll stop there.
There are a number of groups that have published hindcasts, and so we're just looking at the Sea Ice Outlook here.
Yeah.
So we want to be clear that there's a lot more to look at, and there are a number of groups that have published hindcasts, and they're getting fairly good correlations with their forecasts.
I've got a brief comment. Right here. It also brings up, if we really want to get down into the weeds on the statistics, the standard deviation ideas were really designed for reducing measurement error, and we're applying them to wild forecasts here. So we almost have more of a Bayesian problem where we're trying to reduce uncertainty, and we'll never get the ultimate place. So when I saw I remember when they had those confidence limits, they were done fairly formally, which is which is fine, but you know, there's some information that they were all out of bounds. And that's why I go back to the 2008. That was the only year we had the range of all possible physical interpretations.
One more question while I change over. Let's choose. Yeah.
So I was wondering if any of you can comment on the fairness of analyzing statistics and everything of various different methods of making predictions where you combine statistical, heuristic, modeling, and you put it all in the same basket and you try to come up with some conclusions.
Well, I would say that's an empirical question. I looked at this and wondered, what would you find if you did that? And are the conclusions robust if someone else made a different selection or decided only to look at one? I think the individual search teams know where their data came from and what decisions went in and so forth. But the whole point of this was to view it as an ensemble and see what the variation and the center in that was. And well, let me suggest this: the data are out there, and you can subdivide it any way you want. And you know, you could make different cuts than we did, exclude 2/3 of the cases, or however you wished. I think you'll come to the same conclusion. I think that it's that robust. But it's an empirical question, I think.
Thanks, guys. We're going to move on to talk about the workshop challenge, and this presentation is by Ed Blanchard Rigglesworth from University of Washington.
Just converted this from Keynote to PowerPoint, so apologies in advance if every plot is blurry. This actually plot has already appeared once, and I just want to point out that the range among forecasts is quite large, and you know, you can pick some months, for example, July 2008, that the actual range is bigger than the actual observed range in the actual 6 years of the Sea Ice Outlook. And the same story appears in historical hindcasts, so you know, in the last 30 years, and we'll talk more about that later. And well, you know, immediately you can think, well, you know, all these different outlooks use a different variety or range of initial conditions and different information in different metrics, and they also obviously have different model physics and statistics. So how can we tell the origin of that spread apart between those two categories? And ideally, it'd be great if you could run an experiment with all the different forecasting techniques that all have simulated the same initial conditions. And this is a little bit of a poor man's approximation, and I think it also, hopefully, it'll be a good motivator for the model intercomparison project talks that will be later during this workshop. And so the experiment was for the 2013 Outlook, to run an experiment with where we took 1 meter, a negative 1 meter thickness anomaly. So you make the ice thinner 1 meter everywhere. And I'll thank Gina and Ron for doing this with PowerMass, and Richard Clough for doing it with the NASA GMAO. And we did one with our own CESM1. So we've got 3 submissions. And what I'm going to do first is I'm going to show you results from each one individually. Okay, that's not blurry. So, and all 3 will be the same kind of plot. So what I show you here is on the left simply the simulations from the 1st of May, or 1st of June or 1st of April, whichever date that these groups kind of initialize their outlooks on. And what I show you in black is the control, or what would have been the 2013 Sea Ice Outlook, and in red is the experiment. And obviously, you know, if you're going to take a meter of ice thickness away, you are going to have a negative, or you're going to have less sea ice here in September. But what I was interested in is to see what kind of range of answers I'd get, whether all groups would be, say, 10, 20% from each other, or, you know, perhaps 100 to 100%. And what I show you in the middle plot is the area difference between the control and the experiment. So, for example, in CESM, we lose around just over 2 meters, 2 million square kilometers. These are all million square kilometers by July, and then it sort of stays constant, and by September, you're still at the just over 2 million. And what I show you in the right is that 2 of these 3 submissions, we run ensembles, so we can see the growth in the ensemble spread, which you can think of as a measure of predictability. And for example, in our experiment, in the red one, that grows faster. You can see that looking at the left panel, the range of those thin red lines grows faster than the black ones. And if you look at the standard deviation, you can that tells you that. And perhaps you can say that in the experiment, you lose predictability a little earlier. So the black would have been the 2013 SEARCH Outlook, right? And the experiment is the -1 meter thickness in the initial condition. And following for biomass, we get a stronger response. So now we're in the sort of 3 to 4 million square kilometers. And it sort of happens right away. You can see that by July, you know, we're down to only 2 million square kilometers. And so the response in this model is stronger. And another interesting thing is that the spread, actually, you get the opposite response to CESM. So the spread in the red ensemble is a lot smaller than in the control. And I'll show some plots about that later. And this would suggest that the predictability in this case would actually be a lot higher. Because, you know, so we're running it with sort of 7 different atmospheres. And it doesn't matter with which atmosphere you run in, the sea ice is sort of doing the same thing. And finally, coupled to the atmosphere. The biomass is ice ocean, run with the 7 previous summer atmospheres. But I will just point out that if you compare the black line on the red panel in biomass with that with CSM, they're comparable. So the growth in the ensembles in the controls are similar, but in the experiment, they're very different. And lastly, with the NASA, we have a sort of third response where the area difference in September is the largest at just over 4 million, but it does grow a bit more like CSM, sort of more gradually. So what I will do very quickly is just I want to point out, so I've just got these submissions in the last couple of days, so this is kind of a very hashed slide. But if you look at the black line in all 3 submissions on the left panel, they're all fairly similar, but the red ones, the responses are quite different. And if you actually plot them together, so what I'm doing now is I'm plotting the response, or the experiment minus the control in, again, millions of square kilometers, and all 3 sort of do a different thing. So if you just think about it in terms of September, so we have a range from 2.5 down to +4, so almost a 2-fold difference. And you know, we've modified these all in the same way. You know, we've taken 1 meter of ice thickness, so we're getting pretty different responses. And also, if you think about it in terms of the length of, imagine, ice-free season, you know, so if you kind of integrate in time, then, you know, say biomass would have a much longer time where it would be ice-free. No, not necessarily. The perturbation is the same, but each model has just kept its own kind of, or it has applied that perturbation on its 2013 initial condition, which are going to be different. But in terms of sea ice extent, because those 3 black lines were fairly similar, in terms of the extent. Yeah. Okay. So a little bit my take-home message with this is that there is quite a large room for the different model physics to give you a different answer in terms of applying, or if they're forced with the same perturbation. So when you look at that range in the last 6 years of SEARCH outlooks, we don't know yet how much of that range is responsible. Different initial conditions are responsible for that range, but I would argue that different model physics, sadly we didn't have any statistical models here, but even with just numerical models, there is quite a lot of room for the different models to give you, or to simulate a different sea ice outlook. And I just have a couple of minutes, but I thought one of the unexpected but very interesting results were this result about the biomass, the high predictability, and I just want to show these plots, and again, thank Ron and Jin Loon for showing these. And these are the monthly sea ice concentration plots, and you have the control in the left, and the black lines are the sea ice edge in each of those 7 ensemble members, right? So you can see that in the control by August, September, that you have like these spaghetti plots, and that's why that's a measure of uncertainty. Whereas in the experiment, the sea ice edge just goes back to this thick ice that is north of Greenland and Canada. And I thought this was interesting because one, there's definitely some evidence that points out that when you have thinner sea ice, your predictability is going to go down, and this would at least suggest otherwise. And I know this experiment's not really designed to address this question, but I thought this was quite interesting anyway. Exactly.
So the less spread might be resulted that the atmosphere is not responding to your eye in that experiment.
I agree, and so that the question was that you run in this experiment with the atmospheres from the control, which tend to be, sort of would be atmospheres that belong to a colder sort of state, colder Arctic, but. Nevertheless, it shows that the atmospheres in the control have enough variability among them to result in variability in the sea ice, but not in the experiment. So I think that's perhaps something to think about when designing sort of ice ocean experiments. And you can see the one thing though is that when I saw this, I think it makes a lot of sense for September and August because I'm showing you this is the same but with thickness, right? So if you look at the thickness in early June, you only have thick ice in that area, and that's where the sea ice edge goes back to. But I was surprised that in July, where you're losing all this homogeneous or fairly homogeneous ice in terms of thickness, that it all seems to melt sort of at the same rate in spite of the different atmospheres. Just as comparison, I'll show you the one in CESM. And the top is the kind of equivalent plots, and so that shows that the sort of variability in the experiment is a lot more like in the control. And in terms of ice thickness in CSM, it's a fairly similar pattern to biomass. We just have this kind of little bit of thick ice north of Greenland and the Canadian archipelago, but CSM is really good at keeping this thin ice kind of in the middle of the Arctic without melting completely. And that might be sort of, these are September, right? So if you look at September in the top right in the experiment, a lot of that sea ice area actually, these are 1 meter thickness contours in the bottom. So that's actually pretty thin ice that just hangs around between July and September without melting completely. And I hope, I don't have a conclusion slide, but I hope this might be raise some questions and ideas and hopefully motivation for the model-to comparison. And thanks again to those who submitted for this.
We have about 3 minutes for questions.
Can I start myself? I think that one of the reasons why you have different responses in area may reside in the methodology. For me, it's not obvious how to remove 1 meter of ice in CSM, which is, I think, a multi-category ice model. If you remove 1 meter in the thicker category or in the thinner category, you will have totally different questions. And likewise, the 3 models are not running in the same setups. One is coupled, the other is forced. So I think that there must be some physical response that is visible in the area, but also probably an issue of methodology. And probably the next step is to coordinate experiments with exactly the same setups to make robust statements.
I agree completely with that. And I mean, I had my own issues setting up the experiment in CSM, changing, because you have to change the ice thickness categories. It's not a simple way of just taking a meter away, and you have to figure out how you transfer the ice thickness from one category to another. Fortunately, a lot of the ice thickness, or a lot of the ice in the Central Arctic is in category 3. It's like 70% of it. So I think that's, I'll have to go back to the code and see exactly what I did. But, and I think Richard had a similar, I don't know where he is, but he was telling me that they found it pretty hard too. So, these experiments do have a challenge, and I would have loved to have statistical submissions. I thought I'd get more from those, because I think it would have been simpler to run or calculate. But this is just sort of a very early step to help.
I'm also wondering if it's not better to prescribe percentage prediction instead of absolute prediction, because obviously it's not realistic to have minus or plus 1 meter in the marginal ice zone.
Yeah. So we did. I will note that near the sea ice edge, where the controlled thickness was less than 1 meter, then I think Richard took 50% off. I did a similar thing where like a linear reduction. But that I don't know how much of an effect that would have on the Central Arctic, because in May, I mean, that ice is going to melt both in the control and the experiment. Yeah, no, I mean, I agree. There's a lot of issues about how to design these things.
So let's take one more question, and then maybe people who want to stick around at the break is
I was wondering what the rationale was for choosing 1 meter. Sort of, is this an
it was a bit of a guess number to get a response that was strong enough. And I think in a way we sort of got that. But on the other hand, a 1 meter, given what the trend line is, we might be there in not too long from now. So, and I know that, this is a very much a transient kind of response experiment, right? You're just changing one variable. And it reminds me a little bit of Stefan's experiments, where, he took all the sea ice, but it grows back really quick because everything else is kind of in its own climatology. But yeah, so that was, we could have chosen half a meter, but I thought, well, I'll try and hit the system hard enough. But in a way, I think the take-home message is that, yeah, we get different responses from pretty significantly different responses from the 3 different methods.
very much, and I'm sorry we don't have more time for discussion. It's going to be the theme, I'm afraid, of the workshop. But do take the opportunity during the breaks to talk to each other. We have a half-hour break, and so we'll come back at 11:45. Try to watch the clock and be around. Thanks. And when by the way, I guess I've been told, when you talk into the microphone, rock star style, just really get close.
I'm gonna load up.